Alright, so what you're going to look at is question 8, which states generate the SQL code to create the database tables observed from the ERD with all constraints, e.g. primary keys, foreign keys. Include necessary data types and relationships in your script. Alright, so this is simple. What we are going to do is create the code which is going to create this kind of tables in this question. These tables, which are these entities: patient data, training, epidemiological data, supply chain, geographical location. So we are supposed to create tables in this MySQL. So I'm going to run MySQL, and first let me begin by showing you where the code is. I typed it in Notepad. So if you go to Notepad, I think you can be able to see the code. And here everything is underlined because I believe Notepad doesn't understand MySQL. But this is the code. So let's copy the code and go and run localhost. So you put localhost, as you can see, I already put it. So PHP my admin, so we continue root, login. Now we are going to create, we just want to see if this code works. We are going to create a new database, which is let me see if the question has. So we can create any DB. So let's create a new database. Let's call it let me just call it hospital. So that is our database, and we create. So yeah, let's create our database. So let me copy the code and paste it in MySQL. So let me first explain this code before we go any further. Create patient data. We are going to begin by creating a patient data table, which is right here. Patient data table, this one. That is the first. The second is we are going to create a visit record, which is here. Then we are going to create treatment record, which is here. Treatment. Then we are going to create laboratory tests, which is here. Though we have not been given attributes, so we are just going to create a table for it, and I will just find some attributes which I think might be suitable, like test ID, visit ID, the test name. This visit ID is a foreign key. It's a foreign key from the visit record. As you can see here, it has a visit ID. So we can also use it in laboratory tests when the patient visited. So we are also going to create the resource table, and we are also going to create the user role, the one like the doctor, the nurse, the lab technician. As you can see, I define the users of the system here. So if you are not a user of this system, for example, if you are not a nurse, you are not a doctor, you are not a lab technician, you can't be able to use the system. You will not be able to use the system. So I just want to so basically that is my code. I created 7 attributes, stroke tables in MySQL. So this is my code, where the constraints for patient data. First of all, the patient data is a primary key, and it's an integer. So anything short of an integer won't be able to work. It has to be an integer. Let me say 0, 1, 0, 2. That is the constraint that I chose. And first name, the constraint is character of 50 letters. Last name is character 50 letters, and so on. So date of birth is strictly a date. So anything short of a date won't be able to enter the system. Gender is a checkbox, where you're going to be able to choose 3. Short of these 3 options, you won't be able to enter data into the system. We are going to have male, female, and other. So if you come with, I don't know, your kind of sexual visibility, it won't be able to enter into the system. These are the only constraints which we have. And the contact number, this one is supposed to be an integer. This one is supposed to be int. It's supposed to be an integer, not a character, since it's a number. Address can be a text. Yes, so these are my constraints for this patient data, and so on. We can continue for this visit record, which also has a patient ID. So this one is a foreign key. This is a foreign key from patient ID, and its own primary key is here, visit ID, which is strictly a primary key, a constraint. So also the other constraint is that these fields are not supposed to be left empty. It has to be full of a particular set of data as provided with the data type. So let's continue and see. Table 4 is laboratory tests with its own ID, visit ID, this name, and the particular constraints. Primary key not supposed to be 0. This one, IDs, all IDs are going to be filled in automatically by the system, as the primary key is. They are going to be filled in automatically. Yes. So let's continue to the last table is a user role. As I had explained, these are the only users that are allowed to use the system. For example, admin, doctor, nurse, and the lab technician, with its own primary key, which is the user ID. The user must log in with the ID, the username, which is unique. Yes, it's not supposed to be the same name. I cannot log in. Let me say I'm called Andrew. I'm an admin, and the lab technician is also called Andrew. There's supposed to be a difference in the names. Maybe they can add initials to their names, and also the password must be there. It is a character of 255 words, and it's not supposed to be left blank. So basically, this is my code, and we are about to run it and see how it's going to go. All these 7 tables are supposed to be created. So we can press go. Yeah, and it looks like green light. MySQL return an empty result. 0 rows. We have not yet added any rows, so we can just go to hospital, and these are the 7 tables that have been created. So we can the users of the system can begin filling in the data as per the tables created. Yeah, and the system can continue working swiftly. Alright, so basically that is what I just wanted to present. Alright, epidemiological data is related to a patient in this way. One patient can have only this one kind of this data. For instance, like I am a patient, my data is stored in a particular table, which is this epidemiological data. Yes, so only me can have an epidemiological data. I cannot have a lot of it since it's just one set of data, but many patients can also have a lot of epidemiological data. So that's why I chose a 1-to-1 cardinality. Yes, and a relationship is has. Yes. Secondly, the patient data also has a relationship with training, which is also 1-to-1. The epidemiological data is also connected to training. Yes. Then we come to this side of epidemiological data, which according to the question, let's first look at the question. Epidemiological data has dates, location, cases for thousands of people, rainfall, average temperature, this. So in my notation, I just wrote 4 points for each. I wrote 4 points for 4 attributes for each table, for each entity. Yeah. So in my epidemiological data, the first entity that I have in every single entity attribute is an ID, the primary key. For foreign keys, they are there, but I don't think in Cheng's foot notation the foreign keys can be seen. Also in ERDs, I think they can be placed in the cross-fit notation, but in Cheng's notation, I don't think I can be able to show I don't think I can be able to show a foreign key. But the primary keys are always there. As you know, they are always underlined. First of all, we have patient data ID, location ID, data ID, we also have the supplier ID. Alright, so from the patient data, which is now here, now let me say there's a certain kind of disease that has come, and they need to get resources such that they can be able to treat that disease. That's where supply chain comes in. This epidemiological data triggers supply chain to work in this particular location of the hospital, which is the geolocation of the hospital. The geolocation has the village, parish, sub-county. Village, parish, and sub-county. That is the data which is in the entity called geolocation. So the epidemiological data triggers the supply chain to act according to the needs of the patient data. For example, the patient has a certain kind of disease, let me say cancer, and there is no MRI scan, so they will have to consult supply chain, and supply chain will be able to deliver the MRI scans. That is if the funds are there. If they are not there, then I think the system can be able to know. Alright, so in this we are going to continue our relationships. Yeah, now the training entity. As you can see in this, in the question provided, the IDs, we have the training ID, user ID, training type, training date, and completion status. Yes, so in here the training is connected to, is related to the laboratory, is related to the laboratory technician. Yes, is related to the laboratory technician. Yes, so this was an error. Is related to the laboratory technician, not the training facility. So in this data, in this entity, training facility, I think there's only one kind of data that goes into this, which is training ID, user ID, training type, and training date. So this entity has a relationship to the technician of 1-to-1, where one training can only go to the lab technician for review. Yes, and also the cardinality can also be many to many, where a lot of training data can go to the lab technician, and also 1-to-1 can also work. That's why I chose 1-to-1. Yes, that is 1-to-1, and N and N can also work for that particular entity relationship. Alright, we also have from the lab technician, there is a connection, there is a relationship with health facility and the treatment outcome, as seen in this provided question in the cross-foot notation. The laboratory technician and the health facility, and also the treatment outcome, they are kind of related. And here, as you can see, it is one-to-many with this, because in the cross-fit notation you can be able to know the cardinalities between the relationships, it is one to many, as you can also see here. The laboratory technician produces the treatment outcome, which is 1 many to 1 many to 1, and the data from the lab technician, which is got from the patient data, comes into the treatment outcome. That is what is going to define the kind of treatment the patient is going to receive. From the lab, as you know, there is blood tests and whatever. That is how the data is going to be from the lab, according to the disease the patient has. So a lot of data. So the cardinality between the treatment outcome and the lab technician is this. A patient can have a lot of lab tests, a lot of data from the technician. Let me say he or she, the sick client went to the lab and then was tested for various kinds of diseases like blood pressure, tested for cancer, tested for HIV. All that data goes into the treatment entity, where a treatment can be accumulated for the patient. For example, a lot of data defines one treatment. Yes. A lot of data, the cardinality is many to 1. The treatment is always 1. At the end of the day, the patient is going to get out of the hospital with a treatment, which is just 1, not many treatments. Yes. So I chose a 1 to many. Yeah, and also the treatment outcome, there is also a visit record in the treatment outcome. The visit record is connected to the treatment outcome, which is 1 to many, Yes, the treatment outcome and the visit record have a cardinality of many to 1, where many visits can lead to just one treatment. For example, a patient can visit the hospital, Victoria Hospital, just many times and is being offered just one treatment. For example, let me say HIV. The patient has HIV and the treatment is ARVs or injections. That is one treatment. Yes, there are no other treatments. Yeah, so the cardinality is 1 to many, one treatment for many visit records. And also we have a relationship with lab tests and the lab technician. So the lab technician is the one that carries out the lab tests. So the cardinality between a lab technician is, as you can see here in the provided, but in the provided question, it is just 1 to many. There is just many to 1 as provided. So it's many to 1. Alright, the lab technician is the one who carries out these lab tests, and in the question there's only just the entity. There are no provided attributes, but but they have given us the cardinality, which is 1 to many, meaning many technicians can carry out a lab test. Yeah. Okay, so let's continue to the relationship from as you can see, treatment outcome and the visit records. Treatment outcome and the visit records, that one's already explained. Visit record and the treatment. Yes, so there is a cardinality of 1 to 1, meaning one visit records triggers one treatment. So here say triggers one record, one treatment outcome. Sorry, one visit record triggers one treatment outcome. Alright, so in which the cardinality is 1-to-1. As you can see, everything is as required from this cross-fit notation. Here the treatment IDs are kind of different, but here they are underlined. It's supposed to be underlined for easy identification. So the treatment is connected to the user, where one user gets one treatment, and also many users can also get one treatment. So the relationship can be get, where one user gets treatment. As you can see in the cross-fit notation, one user gets one treatment. So let's continue to the malaria type. A user can have a malaria type. A user cannot have two malaria types since they are bitten by one mosquito. So they have to have one malaria type. So let's continue. The cardinality is have, where one user, we will say malaria type have one user. So the cardinality here is have, which is already typed in, cardinality of 1-to-1. So let's continue to the referral, where the user maybe is not referred. Sorry, the treatment is not fine for the user and he has to be referred to a different hospital. One user can only be referred once, as you can see in this cross-fit notation, where the user, the cardinality is 1-to-1, and many users can also be referred many times, so I decided to use 1-to-1. So let's continue to user role. The user role in the system, in this database system, will be logging in. For example, the doctors, they'll have to log in with the role ID. For example, let me say a doctor's ID can be different from a nurse. So this is the difference is going to be here in the role ID. Also the role description, what the doctor does, what the nurse does, and also the name and the date added. They are also included in this Cheng's notation, Cheng's database notation. So basically this is it. This is my database redrawn from the cross-fit notation, where I managed to redraw everything according to how it had been presented to me. So yeah.